This book, authored by the renowned computer scientists James Kurose and Keith Ross, is one of the most popular and influential textbooks for learning about computer networking. Its main goal is to provide a modern and comprehensive introduction to the field, explaining not just the individual components of the Internet, but how they all work together. What makes this book unique is its celebrated top-down approach. Instead of starting with the low-level details of physical wires and data bits, it begins with the application layer, the part of the network we interact with every day, like web browsers and email clients. From there, it moves step by step down the protocol stack. This method helps you understand why each layer exists as you see the services it must provide to the layer above it. The book focuses heavily on the real-world Internet and its TCP/IP protocol suite as its central case study. It emphasizes fundamental principles that remain relevant even as technology evolves, and this 7th edition incorporates modern topics like software-defined networking, SDN. Let's now walk through the book chapter by chapter to understand its structure and core lessons. Chapter 1. Computer Networks and the Internet serves as a grand tour of the entire world of computer networking, setting the stage for everything that follows. It introduces the fundamental building blocks and vocabulary of the Internet. Core concepts. It defines the Internet from two viewpoints: the nuts and bolts perspective of physical hardware, like hosts, routers, and communication links, and the services perspective of the infrastructure that supports applications. It introduces the idea of a protocol, which is a set of rules that governs communication using human analogies like asking for the time to make the concept clear. The chapter outlines the basic structure of the network, dividing it into the network edge, where applications and end systems like your computer live, and the network core, the mesh of routers that connects everything. It explains the two fundamental ways data is moved through the core: packet switching, which the Internet uses, and circuit switching, which traditional telephone networks used. Finally, it introduces the 5 layers of the Internet protocol stack: application, transport, network, link, and physical. This layered model is the organizational structure for the entire book. Key takeaway. This chapter provides a complete, high-level map of the Internet, giving you the context and terminology needed to understand the more detailed discussions in subsequent chapters. Chapter 2. Application layer is all about the software that we, as users, interact with directly. It explains the architecture and protocols behind our favorite Internet applications. Core concepts. It distinguishes between two main application architectures: client-server, where an always-on server handles requests from many clients, like a web server, and peer-to-peer, P2P, where users' machines communicate directly with each other, like in BitTorrent file sharing. It dives deep into the key application layer protocols. HTTP, Hypertext Transfer Protocol, the backbone of the World Wide Web, used by your browser to request and receive web pages. SMTP, Simple Mail Transfer Protocol, the protocol used for sending electronic mail between mail servers. DNS, Domain Name System, the Internet's directory service, responsible for translating human-friendly host names like www.google.com into machine-readable IP addresses. It also covers modern concepts like content distribution networks, CDNs, which bring content closer to users to improve performance, and provides practical examples of building network applications using socket programming. Key takeaway. This chapter shows how the applications we rely on are built upon standardized protocols that define how processes on different computers exchange messages. Chapter 3. Transport Layer focuses on providing communication services between processes running on different end systems. This is where the concepts of reliability and congestion management come into play. Core concepts. It introduces the Internet's two workhorse transport protocols, UDP, User Datagram Protocol, a simple, no-frills protocol that offers a connectionless and unreliable service. It's fast but doesn't guarantee message delivery, making it suitable for applications like DNS or streaming media where speed is critical. TCP, Transmission Control Protocol, a powerful protocol that provides a reliable, connection-oriented service. Before sending data, TCP establishes a connection using a three-way handshake. It ensures all data arrives correctly and in order, and it includes congestion control to avoid overwhelming the network. A key function covered is multiplexing and demultiplexing, which is how the transport layer uses port numbers to deliver incoming data to the correct application on a host. The chapter details the principles of reliable data transfer, explaining how techniques like sequence numbers, acknowledgements, and timers can be combined to build a reliable service on top of an unreliable network. Key takeaway: the transport layer is the critical link between applications and the network itself, offering different service models like TCP and UDP that applications can choose from based on their needs for reliability, speed, and simplicity. Chapter 4: The Network Layer, Data Plane, begins a two-part look at the network layer by focusing on the data plane. The data plane's primary job is forwarding, which is the action a single router takes to move a packet from an incoming link to the correct outgoing link. Core concepts. It provides a detailed look inside a router, explaining its key components: input ports, output ports, a switching fabric, and a routing processor. Queuing, scheduling, and potential bottlenecks like head-of-line (HOL) are also discussed. It covers IP, Internet Protocol, in depth, including the format of the IPv4 datagram, fragmentation, and the transition to the much larger address space of IPv6. A significant portion is dedicated to IP addressing, explaining concepts like subnets, subnet masks, CIDR, classless interdomain routing, and how organizations get IP addresses. It also covers NAT, Network Address Translation. It introduces generalized forwarding and the match plus action paradigm central to software-defined networking, SDN. Key takeaway: this chapter explains the mechanics of how an individual router performs its core function, looking at a packet's destination and quickly switching it toward its next hop. Chapter 5: The Network Layer, Control Plane, covers the second part of the network layer, the control plane. The control plane is concerned with routing, the network-wide process of determining the end-to-end paths that packets take from a source to a destination. Core concepts. It presents the two main families of routing algorithms: link state, LS algorithms, like Dijkstra's algorithm, where each router has a complete map of the network. The OSPF protocol used within a single ISP's network is an example. Distance vector, DV algorithms, where each router only communicates with its direct neighbors to iteratively compute paths. The BGP protocol, which connects all the different ISPs to form the global internet, is a DV-style protocol. It contrasts the traditional approach of per-router control with the modern SDN approach, where a logically centralized controller computes and distributes the forwarding tables to the network switches. It also covers essential network management protocols like ICMP, which is used by programs like Ping and TracerRoute. Key takeaway: the control plane provides the intelligence of the network, calculating the paths that populate the forwarding tables in the data plane and thereby steering traffic across the entire Internet. Chapter 6: The Link Layer and LANs. The link layer, which is responsible for moving packets, now called frames, across a single communication link. Core concepts. It explains link layer services like framing and error detection with a focus on CRC, cyclic redundancy check, a powerful technique used in Ethernet. It dives into multiple access protocols for shared channels, covering random access protocols like CSMA-CD, the basis for classic Ethernet. It introduces link layer addressing via MAC addresses, which are flat, permanent addresses burned into network adapters. The ARP protocol is explained as the glue that translates between network layer IP addresses and link layer MAC addresses. The chapter details modern switched LANs, explaining how switches are self-learning and how they create isolated collision domains. It also covers VLANs, virtual LANs, for creating logically separate networks on a single physical infrastructure. Key takeaway: the link layer handles the nuts and bolts of transmitting data between two adjacent nodes, managing the specifics of the physical medium and coordinating access if the medium is shared. Chapter 7 focuses on the unique and complex challenges of wireless communication and mobility. Core concepts. It explains the difficulties inherent in wireless links, such as signal attenuation, interference, and the hitting terminal problem. It provides a detailed look at Wi-Fi, IEEE 802.11, including its architecture with access points, its CSMA/CA collision avoidance protocol, and its frame structure. It covers the architecture of cellular networks, explaining the evolution from 3G to modern 4G LTE all-IP networks. It delves into the principles of mobility management, explaining how protocols like mobile IP and mechanisms in cellular networks allow users to maintain their connections as they move from one point of attachment to another. Key takeaway: wireless networking is not just Ethernet without wires. It requires fundamentally different protocols to handle the unreliable nature of the radio channel and the constant movement of users. Chapter 8, Security in Computer Networks, introduces the critical topic of network security, covering both the principles of cryptography and their practical application in securing the Internet. Core concepts. It defines the core goals of security: confidentiality, message integrity, and authentication. It explains the foundations of cryptography, including symmetric key systems and public key systems like the famous RSA algorithm. It shows how cryptographic hash functions are used to create message authentication codes, MACs, and digital signatures to ensure message integrity and non-repudiation. It examines how these principles are applied in real-world security protocols, including SSL/TLS for securing web traffic and IPsec for creating virtual private networks. Finally, it covers operational security mechanisms like firewalls and intrusion detection systems that protect an organization's internal network. Key takeaway: securing a network requires a multi-layered approach, using powerful cryptographic tools to protect data in transit and operational defenses to protect the network perimeter. The final chapter, Multimedia Networking, explores the challenges and solutions for delivering real-time multimedia, such as streaming video and voice-over IP, VoIP, over the best effort Internet. Core concepts. It categorizes multimedia applications into streaming stored media, streaming live media, and conversational voice/video. These applications are delay-sensitive but can often tolerate some data loss. It explains application-level techniques used to provide a smooth user experience, such as client-side buffering, prefetching, and adaptive streaming using protocols like Dash. It introduces the key protocols for real-time applications: RTP, Real-Time Transport Protocol, which carries the media itself, and SIP, Session Initiation Protocol, which is used to set up and manage calls. It discusses network-level support for multimedia through quality of service QoS mechanisms, like differentiated services, DiffServ, which allows routers to prioritize certain types of traffic over others. Key takeaway: Despite the internet's lack of performance guarantees, a combination of intelligent application design and network provisioning has made high-quality multimedia delivery not only possible, but one of the internet's dominant forms of traffic. All right, that brings us to the end of this episode. Thanks for tuning in. We hope you found it helpful.